Picture two cars crashing at an intersection. Today you will learn how the total momentum stays the same before and after the crash if no outside forces act. Momentum is a measure of motion found by multiplying mass times velocity. We write it as P equals mv. So a 2,000 kilogram truck moving 10 meters per second carries 20,000 units of momentum. The law of conservation of momentum says that for an isolated system, the total momentum before an event equals the total momentum after. Isolated simply means no external forces such as friction or wind disturb the objects. Now watch two identical carts on a smooth track. Cart A moves right at 4 meters per second while cart B sits still. Before the crash, the total momentum is m times 4 plus m times 0, giving 4 meters. After they bounce apart, cart A stops and cart B takes the velocity 4 meters per second. Check the total momentum after. M times 0 plus m times 4 still equals 4 meters. So momentum is conserved. Next, consider a ballistic pendulum, a tool that measures the speed of a bullet. A 10-gram bullet flies horizontally into a 2-kilogram block hanging from strings. The bullet embeds, and together they swing upward. Step 1. Treat the collision as isolated horizontally, so momentum before equals momentum after. Set the momenta equal 0.01 versus equals 2.01 v. So v equals 0.005 times versus. Rockets also rely on momentum conservation. When the engine fires, exhaust gas shoots backward at high speed. The gas gains backward momentum, so the rocket gains equal forward momentum. Remember, momentum is a vector, so direction matters. In an isolated system, total momentum before equals total momentum after. To solve problems, draw clear before and after diagrams. Write momentum expressions. Set totals equal, and solve for the unknown. Generate your own educational videos for free at eduvids.vercel.app.